Question number 6. Figure 6.1 shows a thin sheet of metal suspended from a hole in one corner at A. The weight of the metal is 0.1 Newton and the center of mass is at B. 6a. Describe in detail how you would experimentally determine the position of the center of mass of the sheet of metal. Prepare a pin, a piece of thread, and a plumb line. You can replace the plumb line by a weight or a load, just a small one. Or you can also use a small stone. Mark 2 other points on the metal sheet, each one on each corner of the metal sheet. Suspend the card freely with a pin at A. Hang the plumb line with a thread on the pin. Mark the vertical line made by the thread. Repeat the same procedure for the other 2 points. The center of mass is the point where the 3 lines intersect. This is the complete description for experimentally design of determining the position of the center of mass. Question 6b. The sheet turns because of the moment of the weight about point A. Define what is meant by the moment of a force. Moment of a force is force times perpendicular distance from the force to a pivot, or the turning effect of a force about a pivot. Number 6c, Figure 6.2 and Figure 6.3 show a thick piece of wood with one corner on a table. Figure 6.4 shows the same piece of wood balanced on the table. B is the center of mass. Ci. Explain why in Figure 6.2 the piece of wood falls to the right, and in Figure 6.3 it falls to the left. Because the weight in Figure 6.2 causes a clockwise moment or falls on the right side of the pivot, while the weight in Figure 6.3 causes an anti-clockwise moment or falls on the left side of the pivot. Cii. Suggest how the thickness of the wood in Figure 6.4 affects its stability. The thicker the wood, the greater its stability because it will have larger base area.